Hello and welcome. So in this video, we're going to continue to talk about functions. If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Let's get started. Now, often there is a confusion between methods and functions. These are the terms that a lot of people use interchangeably. So methods are functions, but we'll have to understand a little bit context related to the object-oriented programming here. So methods are functions which are tied to an object. These are functions that serve a purpose, but you need to call them through an object. You cannot call them directly. Whereas the functions that we talk about in general as the user-defined functions do not necessarily have a dependence on the object. So this is the theory of it. Functions do not need any object and are independent, while the methods are attached or linked to an object. We can directly call the function with its name, while the method needs to be called by an object's name. Functions are used to pass or return data, while methods operate the data within a class. I'll explain that to you in some time. Function is an independent functionality, while method lies under object-oriented programming. In functions, we do not need to declare the class, while to use methods, we first need to have a class because within a class, you'll have objects and the associated methods. Functions can only work with the provided data, while methods can access all the data provided within a class. So if you do not understand classes, objects, and functions, or methods so well, that's totally okay. I'll try to give you a quick example of it. And then we'll move on to something called as lambda expressions. So let's say we define a class. Class is called a blueprint of an object. So for example, if you study in a school, you are an object or an instance of a class student. If you work in a company, you are an instance or an object of a class employee. So it's an overarching term which talks about what you in general are. It's kind of a blueprint that this is an employee. A company is supposed to have these pieces of information about an employee. Let's say we are talking about an app which essentially tracks the name of the person and the steps that this person walks each day. So we are defining a class called person, and we are initiating something that's known as a constructor. It's a kind of method which is used to initialize the values inside a class. Observe that we're using the word define, and it's called init because it's supposed to initiate certain values. What are the values that we are interested in? We are interested in initiating the name and the steps. And self refers to the instance of the object. So if I talk about myself, let's say I put my height and age, or I put my name and the steps that I walked today, that will be my instance. So self makes it an instance. There could be so many other people who'd have a different name and they would have their own instances. That's what it is. And then we're defining a function which prints some output. So it's called my function, which takes the input through this constructor and displays a message. Hello, my name is self.name and a period. And then we're writing I walk these many steps each day. Now notice the way I'm printing it right now is actually through concatenation. There's a way you can operate on strings. That's why when we called a numerical value, I had to convert it to a string using again an inbuilt function called str. So in order to use this, we'll have to first call the class person and give it an appropriate input to initialize it. We'll have to give, let's say, the input called name and the steps, and then we can call my function. Notice there's a difference in the way we are calling this my function. This my function is not being called directly just by typing my function. We are calling it with respect to an object that we've created for the class. This particular object, P1, is an instance of the class person. Why? Because this is some specific person whose name is William and who has walked 10,000 steps. There could be another person, Nash, who has walked 15,000 steps, and that will be another instance. So this is being called with respect to an object. That's why you're writing P1.myFunction, and then it'll work. So methods are functions, but those are attached to the objects. There is a concept of object-oriented programming. Once again, if you do not follow object-oriented programming much, that's totally fine. You'd be able to still manage your work, but just wanted to call it out. Because a lot of times in Python codes, you'll be working on data frames, etc., and you'll be straight away calling dot a specific method. Now let's move on to the lambda functions and what is the use of a lambda function. So lambda function essentially is a function on the go, which does not require the conventional definition like the use of define keyword, etc. Lambda syntax is that it requires the arguments and the expressions. So I'll show you what it does. So let's say we take a number and we want to add 5 to it. You could have defined a function for this that add a value of 5 to this number. In lambda functions, it works straightforward. We are giving lambda as the keyword. We are giving the arguments. What is the argument? A is the value that we'll be passing. And then what are we doing? The expression is what we are doing with that value. We are adding 5 to it. So lambda arguments, which is a specific value, and what we are doing is the expression. So if we print x3, which means we are putting a as 3, it should display 8. That's it. So it avoids the use of the keyword define and return and things like that, and straight away works on the go. Generally, you will use this in a combination with functions like map or filter. And let's quickly look at what do these do. So let's say we have to square every possible number within a list. We are defining a function called square, which takes an input and does a squaring of it. So these two asterisks basically represent exponent, x raised to the power 2. This is our list. And with the help of the map function, which is again an inbuilt Python function, we need to give two inputs. What is it that we want to do? And to what object we want to apply this. So we want to square, this is the name of this function, and we want to do squaring of what? The elements present in this list. This is the convenience that the map function brings. It is allowing us to modify the list that we had with the help of a user-defined function. Now, the only thing is that it does not return a list as an output. So if you also want the output to be a list, you'll have to take this and pass this to the list, which is again an inbuilt function, and you can print the outcome. It says it has squared all these numbers. So 1, 4, 9, 16, and 25, the squared values of these numbers. Just like map, we have an apply function. Now, apply is something which is specific to Pandas data frames, works in a very similar way. So we have, let's say, a data frame. We're creating the simplest data frame using a dictionary key value pair. This will be the name of a column, and the column contains these values. And we call pd.dataframe to convert this dictionary into a data frame. Now we are doing the same square function that we defined some time back. And what we are doing is to our data frame, which has a column called num, we want to add a new column called squared, which will have all these squared values. And then we are printing the data frame. And you can see it will have two columns. First is num and the other is squared. So these are the functions which have some basic differences. For example, map is a Python inbuilt function and applies something which is specific to Pandas library. So it essentially is applicable for data frames only. And there are a couple of other differences. Now let's see how do we actually use some of the Lambda functions, because we originally started talking about the Lambda functions. So let's say we have a list. This is our list of numbers. And what we are saying is that we want to filter the numbers which are even numbers. So we are not again using some keywords like define and return. What we are saying is that we'll take a Lambda function. We'll mention what's the argument and the expression. What is the expression? Expression says if the input is divisible by 2, which means the modulo of that returns 0, then you return the numbers. So if the input is divisible by 2, that is meaningful for us. And on what data are we checking this? So we'll have to mention the list as well. So filter takes again two arguments, the specific condition on which you want to filter and on what object you want to apply the filter. And once again, we'll have to convert the output to a list if you want to print a list. So it works pretty much the same way. You can get 2, 4, 6, 8, 10. Another important function that we can use together with Lambda function is called sorted. So let's say we have these names of individuals and we want to sort these names by the length of the names in a specific order. So this is a list and we are giving the input, which is again the same list, and we're mentioning on what key we want to sort this. So we're saying that we want to sort this on the length of X. Let's see what's the outcome. So in the alphabetical order, starting with the words or the names which had the least number of alphabets. So Don, Eva, then Alex, then Bobby, and then Charlie, because this has the highest number of alphabets. It's a logic that we gave, and sorted function has done a sorting for us. There's a similar sounding method called sort, and let's see how does it work. So sort is a method that can be called on a list object. Now this is attached to a list object, and that's why we're calling it a method and not a function. Sorted was called directly. It was not tied to an object. So this is a function and this is a method. So we have a list here, and let's say we want to just do a sort. We do a dot sort. Let's see what does it do. It just does the sorting in place in an ascending order from the smallest values to the highest values. There are some subtle differences between sort and sorted. For example, sort modifies the original list. If you had a list called numbers, which was like this, and after you perform sort, if you try to print numbers again, it will be giving you the sorted output. On the other hand, sorted returns a new sorted list. So when we applied sorted here, it would not really change the actual names list. It has given us an outcome as we wanted it. That's one main difference between sort and sorted. So when to use sort? If you need the output to be sorted, and that's how you'd want to work with it further, you can use sort. But if you need just the temporary view of the data, you want to get the outcome, but you don't want to really make a change to the source, you can use sorted in that case. Let's take the last example here, which shows sorting with respect to a variable when you have multiple variables available. So let's say we create a simple list of dictionaries. These square brackets represent a list, and inside which we have dictionaries, keys and values, keys and values. So key is name, value is Alex, key is age, and value is 25. So on and so forth like this, we have multiple entries for different individuals. And let's say we want to do a sort on this. What do we want to sort on? Let's say we want to sort on age. So we want to get the outcome, which will be sorted by the age. And we also want to maintain the association between name and age. So it should not be just an independent sort. It should accordingly place Alex, accordingly place Bobby with respect to the age. Let's see when we do this sort. So in this case, what is the key? We are mentioning that we want to do the sorting on the age. Lambda function says that we want to apply it to the object called students. So this is the argument. And within that, the expression that we are focusing on is the age. And that's where the sorting would be applied. So it should result into an output which will be sorted by age. You can see 22 first, then 25, and then 28. That was not the original order. Can we give multiple arguments to Lambda functions? Yes. So for example, here we are saying we want to, let's say, do addition of two numbers. We saw that through a simple custom function that we defined some time back. But through a Lambda function also, we can do that. These are x and y, let's say two values. These are arguments. And what do we want to do? We want to do an x plus y. Add is the name of the variable where we are storing it. And when we print the outcome, it will display the output as 7. So to conclude, Lambda functions are efficient whenever we want to create functions that will only contain simple expressions. When we are doing a very simple task, Lambda functions come quite handy. But if you're doing a much complicated code, you have several for loops, if-else conditions, etc., then Lambda might not come that handy. And also, since we define it on the go, we don't have a specific name to call it again. Whereas if you need a function again and again, it'll be then better to define it like a proper function using the keyword define and depending on whether you want to return something or not. So that was pretty much about the functions in this video. This would give you a good starting point whenever you come across functions in any code while you're working on data. At least you'll have a fundamental understanding of what a function is trying to do. And the complexity that a function can cater to would depend on what logic we are bringing to the function. So we can put those conditions in a complex way inside a function. The convenience is that once you do it, you can always use it multiple times. You don't have to redo it every time. In our subsequent videos, you'll see we'll write certain functions, write certain pieces of code, which will be there to make our life a lot easier. Hope this helps. Thank you.